and in this session we are going to discuss deletion operation. The main objective of this video is to learn about deletion operation in a heap structure and concluding the heap sort technique. By watching this video, the students can learn how to delete nodes from a heap and how heap sort is implemented. So one of the important operation is deletion operation. This is the array in which we can find the data that are to be heapified. So the elements are 4, 3, 7, 1, 8, 5. So in this order, if a heap is constructed without any swappings, then it looks like this. 4 is the root because it is in the first position, and 3 as the left child, and 7 as right child, and 1 as 3's left child, and 8 as 3's right child, and only one child is left, that is 7's child. But this is not satisfying the max heap property. This is not satisfying the max heap property. So because 8 is the maximum element and you cannot see 8 as a leaf node in a max heap, you cannot directly swap 8 with 4. Instead, you can swap 8 with 3. So 8 here, 3 here, and then again you have to swap with 4. So 8 at the root and 4 at the left child. Again in this right subtree you are having the root element as 7 and it is satisfying the max heap. So now the tree becomes like this: 8 at the root and 4, 7 as left and right children respectively. And for this left subtree, you can see the root as 4, that is the maximum of the two children. And similarly in the right subtree also, you can see 7 as the root, which is the maximum element in this subtree. And as a whole, 8 is the root for the entire tree, which is the maximum element. So max heap is built. Now I want to perform the delete operation. How to perform delete operation? So first I have to delete the root node by swapping the root element 8 with the last element in the heap. So 5 is the last element in the heap, and if you can swap these two, what happens? 5 occupies the root position and 8 is printed in the output. So 8 is not part of this heap again. But this tree after deletion, it is not satisfying the max heap property because 7 is the maximum element. I have to swap 5 and 7. Then 7 occupies the root position and 5 comes to this right child, and the heap satisfies the max heap property. So after swapping 7, 7 occupies the root position and 5 the right child. Once again I want to perform the delete operation. So the root position 7 is swapped with the last element. This is the last element. 3 is the last element. Because 8 is not part of the heap, 3 is the last element. So swap 7 with the 3. So 3 will become at the root position and 7 will be taken out of the heap and copied into the output stream. But this heap is not satisfying the max heap property. See here, 5 is the maximum element and it should occupy the root position. So simply swap 3 and 5. So when you swap 3 and 5, 5 becomes the root and 3 the right child. And then it satisfies the max heap property. Now, again I want to perform the deletion operation, and the root node is deleted by just swapping it with the last node. So here 1 is the last node. However, 7 and 8 are not part of the heap. They are copied into the output stream. So when you swap 5 and 1, 1 occupies the root position and 5 will be copied to the output stream, and it is not part of the heap. But after this deletion, this heap is not satisfying the max heap property. So what is the max heap property? Always the root node should be the maximum element. Here the maximum element is 4. So 1 is less than 4. Hence it is violating max heap property. So simply swap 1 and 4. So if you swap 1 and 4, 4 occupies the root position and 1 becomes the left child, and hence it satisfies the max heap property like this. 4 is the root now, and then I want to again perform the deletion operation. And 3 is the last node because all the 5, 7, 8 are not part of the heap and they are copied onto the output stream. So simply exchange the root node with the last element so that 3 becomes the root and then 4 will be copied to the output stream, and henceforth it is not a part of the heap. So no need of any swapping, it is satisfying the max. Again I want to perform the delete operation, and 1 is the last element and 3 is the root element. Simply swap these two so that 3 will be added to the output stream and then 1 becomes the root. And again if you perform a delete operation, what will happen? 1 is also added to the elements are in sorted order. Delete continuously all the elements in the max heap or min heap. Finally what will happen? The nodes will be outputted in a sorted order, either ascending or descending. So this is nothing but heap sort. For heap sort to work, first we have to insert and construct a heap, insert elements and construct a heap. and then continuously delete the heap elements. And when you delete, if there is an imbalance in the heap, reheapify and once again delete and continue the process until all the elements in the heap are deleted and the sorting order of the elements is formed. So this is called as, so the ordered elements are now placed in this array as 1, 3, 4, 5, 7, 8. And this is also called as in place sorting because the same array is used for input of the sorting technique and the output of the sorting algorithm is also stored in the same array. In this heap sort, one parameter, input parameter, that is array, and the size is not mentioned here. The size will be given by the user. So within the function of this heap sort, heap size is equal to capital N. So this variable will be populated by the user. And there is a build max heap function call passing one parameter array. So the array is passed to this function build max heap. So what happens in this build max heap function? The heap is constructed one by one, and whenever you insert a new element, check whether the heap is satisfying the max heap property or not. If it is not satisfying, reheapify, balance the heap, make it max heap, and once again start inserting. In that way, one element at a time, insert all the elements one after the other and build a max heap. After building the max heap, what you have to do? In order to get the sorting result, you have to continuously delete the elements in the heap in order to get the sorting order. For that reason, you are using a for loop and you are taking the index variable I, which is initialized to the n. What is n here? The size of the array. That is the last element last element index is initialized to I. And then you are repeating it until it reaches 1 and decrementing it because you are starting with a big value. So in this for loop there are 3 statements, and the first one is a swap function call. So you are calling this swap function in order to swap the first position element with the last position element. What is there in the first position? The root node. So for performing deletion, you have to swap the root node with the last element. What is I here? I is equal to n, that is the last element index. So you are swapping these two. And after that, what you are doing? You are reducing the heap size by 1 because the last element is already considered for sorting and it is removed from the heap. So the size of the heap is now reduced by 1. The next one is again a function called max heapify because you deleted the root node with the last element and now it may not satisfy, the heap may not satisfy the max heap property. So you have to reheapify the heap in order to make it satisfy the max heap property. For that purpose, you are calling this function max heapify and passing the array and the root element and the heap size, and this for loop is repeated for all the nodes in the, it is having the time complexity of order of log n.